Good morning. This is George Chen from International Education Foundation. I'm here to present the topic, Close Up the 100 Years Gap of Fundamental Physical Theory, how to design an experiment to test the light speed invariance to moving observers. Light speed constancy is the fundamental assumption for modern physical theory. People may take it for granted. However, even though the light speed invariance to moving emitters was well established and proved, the light speed invariance to moving observers was never proved by any experiment for more than a century. Some so-called proof is just inference or argument. For example, the Michelson-Morley experiment only proved that the light speed variance, if any, is much smaller than the Earth's speed, 30 kilometers per second. The lack of proof of such a key assumption for 100 years is alarming. It may be the potential Achilles heel of the modern physics theory, if any can be imagined. The key problem is not to detect the timing difference of a light. As a fact, if we measure the so-called one-way light speed, it's never a constant. The key problem is how do we overcome the arguments of time synchronization and time dilation. And the most difficult part to overcome the argument is that no formula to quantify the impact of time synchronization and time dilation, so it makes the assumption almost impossible to be falsifiable. How do you dispute arguments that can be quantified? And our approach will leverage the well-established light speed invariance to moving emitters. We will mirror the experiment setup and make it completely symmetric as to moving emitters and observers. Under this setup, if the result shows the light is synchronous as to moving emitters, it must also be synchronous to moving observers. The basic idea is to tie the testing of two theories together so that no argument can be made, because if you argue against the light speed invariance to moving observers, you basically are also arguing against the light speed invariance as to moving emitters. First, we will have a symmetric experiment set up with two sets of emitters and sensors to measure the light traveling time. Second step, we will align the setting so that each sensor detects the light from both emitters simultaneously, which demonstrate the light speed invariance to moving emitters. And finally, after the alignment, we will check if the light is also synchronous to moving observers. So here is the picture of the experiment setup. Two same sets of emitters and sensors move from the same position at the same speed, but in different directions. A digital scope is used to measure the light traveling from each emitter to each sensor, so there are 4 timings to be measured, T11 to T22. A high-speed camera is used to capture the moment the photon reaches the sensor. If the experiment is properly aligned, according to the light speed invariance as to emitters, the light from both emitters should reach each sensor simultaneously. So basically, we should have T11 equal to T21 and T12 equal to T22. So now, the positive result means if the result shows the light also reaches both sensors at the same time, which means all timings are equal, we prove the light speed invariance to moving observers. The negative result means if there's a time difference, for example, this value predicted by asymmetry theory, that calls into the question of the light speed invariance to moving observers. The experiment can also be improved. For example, we can replace the sensor with interferometer so that we can measure the exact timing. Alternative test is to test if the light speed is isotropic to the moving observers. So we can measure the relativistic mass ratios using the incremental momentum divided by incremental velocity. And we can measure the ratio of a particle moving at a constant high speed, for example, 0.5 c, but in opposite directions. And then we can check the measurement result. If the light speed is isotropic, as predicted by special relativity, the ratio should be the same. But if the result shows a big jump of the ratio, as predicted by asymmetry theory, then a further investigation is required. Final conclusion, the light speed invariance as to moving observers was open for more than 100 years. Our experiment can test this assumption and overcome the arguments of time synchronization and time dilation. For more details, you can read the 2 papers I published. One is asymmetry theory derived from the principle of constant light speed, and the second is the design of experiments. Thank you.